This week we've covered one major topic, but a bunch of other smaller things. So let's go over everything we've seen. We started by looking at big projects, and we saw that we can organize a large project by breaking it up into smaller files. All the files live in the same directory, and they all show up in our processing window, each file in its own tab. Conceptually, when we hit the Run button, they all get mushed together, so processing doesn't care how we break things up. But for us humans, breaking up a complicated project into lots of smaller files can often be a very nice way to organize things. Then we looked at the major topic this week of classes. We saw that a class can be created by simply telling processing we're creating a new class, giving it a name, and then giving it a list of the variables that every object in that class will have, a constructor to make a new instance of that class, and methods or messages that we can send to those objects. The example we used was that of a car, so a car had a bunch of variables and it had a bunch of methods. The constructor is a little bit weird, so we looked at that separately, and we noted that the key things about a constructor are it has the same name as the class, it doesn't have a return type, and it doesn't have a return statement. Nevertheless, it constructs a new object of this type and returns it. The way we use this to create a new object is we give processing the keyword new, followed by the name of the constructor, and then whatever arguments it might take. So the name of the class, the name of the constructor, and of course the constructor when we call it, all have the same name. When we put everything together to make a car, here is a very simple car class. Typically, we save each class in its own file, so this would produce a tab in our main window named car. Once we've defined this class, we can create lots of instances and start sending them messages. A really great way to create a lot of instances is an array. An array of our own objects from a new class, like car, is created the same way we make any kind of an array. First, we declare it to be an array of that type. Then we call new, and we tell it to actually create enough memory to hold a certain number of those. And then we run through each one actually calling new to construct the instance and saving it into the array element. A really important quality of classes is subclasses. We saw that we can create a subclass of any class and give it new variables, a new constructor, and new methods. The subclass inherits all the variables and all the methods from its parent class, but then it adds more. There are three key things to keep in mind when we create a subclass. First, on the very first line where we declare the class, we include the keyword extends, followed by the name of the class that we are building upon. Secondly, in the constructor, we tell the parent object to construct one of itself, and we do that by calling super and handing it any arguments that the constructor might take. Finally, anytime we want to refer to a method in the parent class, we get to it by prefixing it with super dot. You can think of the keyword super as a reference to the parent class. We also looked at a convenient way of drawing with subclasses when transforms are involved. My typical approach is to create a little routine in the parent class. This does all the transformations required to get us in the right position and orientation and scale. Then each render routine, both for the class and the subclass, can push the matrix, call this routine, now we're in the right spot, we can draw whatever we need to draw, and pop the matrix. As we saw, this is great because it lets us do some complicated transformations, but we only have to put them in one place. We then moved on from the topic of objects and classes and covered some odds and ends. The first one was Offscreen Drawing. This lets us prepare a picture in computer memory and then just splat it to the screen very fast anytime we want to draw it. The process begins by declaring a new object of type pGraphics and then creating that object by calling createGraphics, giving that routine the width and height of the little graphics object we want to make, along with the name of a renderer, which I recommend for now and for quite a while you simply use Java 2D. To draw into this buffer, first we send it the message begin draw. It takes no arguments. Then we can call any routine we want. We can call drawing routines, color setting routines, curves, images, transformations, anything we want. But we always have to make sure it's a message that we're sending to the pGraphics object by naming the object followed by a period. Otherwise, that message gets sent to our normal graphics window. When we're done creating our image, we tell processing we're finished by sending the buffer the message end draw, again with no arguments. From then on, we can display the image of this off-screen buffer as though it was a photograph. We just call image, we name the buffer, and we give it the upper left corner in the on-screen graphics window where we want the picture to be drawn. We then saw that there are a number of built-in routines for finding out the current time, the current day, month, and year, and how many milliseconds or thousandths of a second have elapsed since the program started running. The last one, millis, is most useful when we want to determine how much time has elapsed between one event and another. Then we looked at text files. We saw that to read a text file was almost no effort at all. We just call load strings with the name of the file as a string, and we get back an array of strings, one string for every line in the text file. To write a file takes a bit more work. We first declare a new object of type printWriter. Then we create it by handing a string to createWriter. That string contains the name of the file that we want to write. By default, that file will be created in the same directory as the sketch itself. Now we call print and printline as usual, handing it whatever arguments we want to have printed, but rather than printing those things to the output area, we precede it with output file dot. That then tells processing that our print and printline statements are messages that get sent to the output file. When we're done writing to the file, it's very important that we wrap things up. We do that by sending the message flush and then the message close to the output file. I then described the general ideas behind doing work in 3D, but we didn't go into much detail. Finally, we talked about how to share your work. We found that you can export your sketch so that you can include it as a web page in any browser. You can export the application so it's a standalone program, or you can use the tools that are offered at processingjs.org to prepare a version of your sketch that can run on mobile devices like smartphones and tablets. Finally, we saw where you can go from here. You can use one of the many libraries that people have developed and shared for free on the Processing website. And I recommended checking back at that list every so often because it does change and grow over time. We saw that you can download your processing sketch into a small, inexpensive one-board computer called the Arduino. The Arduino is designed to make it easy for you to control any kind of hardware device using your processing sketch. And finally, we saw, now that you know processing, it's a small step to becoming a Java programmer, and from there, another small step to learning any of the many programming languages that are used by professionals for all kinds of programming work today. I've had a great time preparing this course and sharing all this information with you, and I hope that you've had a great time too. I know that you're going to use your new skills to create wonderful and amazing work.